Students, now I am going to teach another axis theorem, that is a perpendicular axis theorem. It is also very important 5 mark question. The perpendicular axis theorem, it is also used to explain the moment of inertia of the body. Okay, so the statement for the perpendicular axis theorem, it is a state that the moment of inertia of plane laminar body about an axis perpendicular to the plane, perpendicular to the plane is equal to sum of moment of inertia of a two perpendicular axes lying in the plane of the body. Okay, so here you need to understand the moment of inertia of the plane laminar body means we are going to calculate the moment of inertia for the thin plane sheet. Okay, that is one of the laminated sheet like this. Okay, so the moment of inertia of the plane laminar body about an axis perpendicular to the plane is equal to sum of moment of inertia of two perpendicular axes lying on the plane of your body. Okay, here there is a three axes on the body. The three axes are mutually perpendicular to each other. Okay, there is a three axes on the body. Here these three axes are mutually perpendicular to each other. Okay, so we consider the x and the y. We consider the x and the y are the perpendicular axis. It is lie on the plane. Lie on the plane. The x and the y are mutually perpendicular to each other, and it's also lie on the laminar body. So the moment of inertia about the axis x and y, the moment of inertia about x and y axis is given by the iy and ix respectively. Okay, so we are going to calculate the moment of inertia of another axis, the moment of inertia of laminar body about the z axis is noted by letter iz. So iz is equal to sum of moment of inertia of two perpendicular axes lying on the plane. We are taking the x and y are lying on the plane. The z is perpendicular to the plane means here the moment of inertia about the perpendicular axis z is equal to sum of moment of inertia of the two perpendicular axes lie on the plane. So we can write Iz is equal to Ix plus Iy. Okay, now we are going to discuss about the proof for perpendicular axis theorem. To prove perpendicular axis theorem, we consider a laminar body. Okay, that is a thin sheet. It has a thickness is very small. It is negligible thickness, and we are taking the origin of the body is O. And we consider the three axes. One is x axis and another one is y axis and z axis. Here these three axes are mutually perpendicular to each other. Okay, the angle between the axis is 90 degree, mutually perpendicular to each other. Here the x axis and y axis are lie on the plane laminar, Here the z axis is perpendicular to the plane, perpendicular to the normal of the plane. Okay, it is perpendicular to the plane. Okay, so in this we consider one of the point mass. The point mass is noted by letter P. It has a mass is m. It is placed at a distance r from the origin. Okay, we consider one of the point mass. The point mass is m. It has the point mass is not a letter P. It has a mass is m. It is placed at a distance r from the origin. Here this lamina is consist of more number of point mass. Okay, so it has a large number of point mass. Okay, it has a large number of point mass. Okay, students. So we are going to calculate the moment of inertia of the particle, the moment of inertia of the point mass is calculated by using the formula of of the particle or point mass P. Okay, the moment of inertia of the particle is calculated about the axis Z. About the axis Z. Okay, about the axis Z we are calculated moment of inertia for the point mass Pm is equal to, already you know the general expression, that is product of mass into square of the distance. So the point mass, it has a mass is m, it has a distance is r from the z axis, so we can write m r square. So already I told to you here this lamina is made up of the large number of the particle, so we need to calculate the total moment of inertia. Means the moment of inertia is calculated, that is the moment of inertia of the entire, the moment of inertia of the entire lamina about z axis is calculated by the summation of, okay, we consider another point like this. Okay, so here the summation of all the points is give the total moment of inertia of the lamina, so we can calculate the moment of inertia of the entire lamina about z axis is calculated by using the summation of this equation. So the summation m r square. Okay, so here the total moment of inertia of the entire lamina about the z axis is noted by letter Iz, that is a moment of inertia about the z axis. So Iz is equal to summation m r square. Okay, so according to this point, here the r is one of the distance from the origin. Here this r is having the displacement in x axis. For calculate this we are to the normal line. Okay, up to this point on the x axis, here up to this point, here it has a displacement is also calculated by y axis. Here this displacement is also calculated by using the x axis, so we are noting the distance is y, this distance is x. Okay students, so this distance is also equal to this distance. Here this distance is also equal to this distance. So by using this concept we are taking this is y, this is x. Okay, so by using this concept we are going to calculate the values of r. For calculate the values of r we are taking this triangle. In this triangle we are taking the values of r square. Means what is r square? R square is equal to, here this value is, it is x, so x square plus this value is equal to y, so r square is equal to x square plus y square. So this formula is substituted in this equation, means Iz is equal to summation m into what is r square, that is x square plus y square. So in next step it can be written as Iz is equal to summation m x square plus summation m y square. Multiply the summation m multiply inside, means Iz is equal to summation m x square plus summation m y square. So Iz is equal to, what is the meaning for summation m x square? The point mass is along the x. Along the x means it is calculated by using the y. So here it is equal to Iy. This is a moment of inertia about the axis y. Next summation my square. My square is the point mass along the y axis. So this is the moment of inertia about the x axis. So it is given by the Ix. So from this we can write Iz is equal to Ix plus y. So the perpendicular axis theorem hence proved. Okay, from this we can write the moment of inertia of the plane laminar body about the axis perpendicular to the plane. About the axis perpendicular to the plane is equal to sum of moment of inertia of the two perpendicular axes lying on the plane of the body. Okay students, thank you. These are the important 5 more questions students. So study well.